This tutorial is designed to show you how to georeference a raster image file. That is, to apply a vector object or georeference object to the raster file of which you know the geographic coordinates of. To do this, we'll be using a GIS software called TNT MIPS or micro images, and so we'll start by loading up micro images. And it works from a main toolbar, and then you open up the tool that you need, in this case Georeference, and the windows pop up. We'll start by opening our file. In this case we have a raster vector CAD file, or RVC, and the first thing that it wants you to do is specify what coordinate reference system you want to put your project in. So we're going to reference it to NAD 27, North American Datum 27, and our coordinate space will be geographic 2D, longitude and latitude, and then we'll go ahead and select our UTM zone. In this case it is UTM zone 10 north, because we're going to be in California. So we say OK, and we're going to select the affine georeference model. So again, it pops up your second window, and we'll just arrange our screen here, and start by zooming in on the first coordinates of the map in the lower left hand corner. And so you'll enter in your longitude, which is west 117, 7 minutes 30 seconds, and our latitude, which is north 33. And then we'll come to this window and we'll select our locator, and we'll place that point right at the corner of the map. We'll right click to set the place, and then we'll move our view up to the next corner. Again, we're at west 117, 7 minutes 30 seconds, and north 33, 7 minutes 30 seconds. Pop over here, set your point, oops, right click, and that's on there. Yep, looks good. Okay, moving on. We are at west 117 and north 33, 07, 30. Select our point, right click, move on to the next. West 117, north 33. And select the window, set your point, and right click. And then we have 4 interior points that we're going to set, so we'll zoom to full scale and use our zoom tool to approximate the location of where that point is supposed to be. And we see it here. Okay, so this time though we're going to start with our point selector tool, and we'll notice over here that it predicts the location, and so then all we have to do is just round to the nearest whole number. We'll say OK, and then we'll hit the check to set our point, and then we'll pop over to the next location, and look at that, I guessed pretty closely about where it's going to be. So I'll set it 30 minutes, 30 seconds, and hit the check. Okay, 2 more to go. We're going to zoom, first full scale, and then approximate the location of the point, which is here. Zoom again, set the location of the point, predicts, we're going to get rid of our sub-seconds. Looks good. Check. And our last point's going to be about here. Zoom out to find it. Can be a tricky thing to find. Oh, there it was. And since I just saw it, I'm going to hit previous view, previous view. Sometimes they're tricky to find. There it is. Okay. So we'll zoom to that location, set our point, adjust. This time we have to round up, so we'll say 30 seconds, and this one's dead on. Check. And then if we look down here below, we have what's called an RMS, or residual error. And this is represented in feet, just because of the method that the affine model that we set up, and so we know that we have an approximate error of about 4.48 feet, which is well within an acceptable range. So we'll go up to File and save this georeference object and say OK. And what that does in essence is save the vector file within the raster vector CAD. So just to show you what that means, we will open up File Manager, and I guess first we'll close our georeference there so we can access it. And when we go into the file, we have the symbol for the raster, but then inside the raster we have this lovely georeference object that has our NAD27 UTM Zone 10. So we have successfully georeferenced a file.